Hello everyone. This is class 12th. Topic is haloarene and its preparation method. In previous videos we have covered haloalkanes. Now next organic compound is haloarene. Let's understand its general formula. Benzene ring if connected with directly X. X means fluorine, chlorine, bromine, iodine. Such compounds are known as haloarene. Fluorobenzene, chlorobenzene, bromobenzene, iodobenzene. In benzene, we will have 5 hydrogens there. Here we have 6 carbons. Every carbon will have sp2 hybridization. Now, how we can prepare fluoro, chloro, bromo and iodobenzenes? The very first method is from benzene and halogen in the presence of Lewis acids like AlCl3, FeCl3, AlBr3 or FeBr3 or FeI3. These all are Lewis acid. First, let's discuss what are Lewis acid. Those molecules in which central atom have vacant orbital for gaining of pair of electron. Like AlCl3, aluminium is making 3 covalent bond with chlorine. In this condition, aluminium will have vacant orbital on it. In this vacant orbital, it can gain a pair of electron. So this whole molecule is working as Lewis acid. Similarly, in FeCl3, the iron is in +3 oxidation state. Outermost electronic configuration of iron is 3d6 4s2, like this. But in FeCl3, because iron have +3 charge means shortage of 3 electrons. So 3 electrons I am removing here. Now you can check 3d6. So 2 electrons from here, 1 electron from here. Now after de-excitation, you can check a vacant orbital can be generated over there. This is a vacant orbital which iron can use to gain pair of electron. So iron means a central atom have a tendency to gain pair of electron. That's why FeCl3 or aluminium bromide, FeBr3 or even FeI3, they all are Lewis acids. They have a tendency to gain pair of electron. Now how they will work there in this preparation method, let's understand. First, let me clarify. With this preparation method, we can prepare chlorobenzenes and bromobenzenes. If we want to prepare iodobenzene with this preparation method, we need one more chemical, oxidizing agents. And fluorobenzene preparation is not possible with this method because we need halogens. If I will use direct fluorine here, already we have discussed that direct fluorination, use of direct fluorine is not possible because reactions are highly uncontrollable. And with iodine, always we need oxidizing agent. Reason already we have discussed. In this video also we will discuss it again. Now let's understand the whole preparation method. First I am going to write a direct reaction. Suppose I want to create chlorobenzene. So first I need benzene, this one, and the halogen. Chlorobenzene you want to create, so chlorine. In the presence of any Lewis acid like AlCl3, and temperature will be there, you need to heat it. So what to do? Any hydrogen you can replace by chlorine. 6 hydrogens are there. Any hydrogen you can replace because all are symmetrical right now. There is no difference between any hydrogen, any I can replace. So suppose I am replacing this hydrogen. So chlorine will come here. Side product, out of 2 chlorine, 1 is substituted there and 1 will come with hydrogen. HCl will be the side product, and AlCl3 after its work will regenerate again like in this form. Let's understand the mechanism of the reaction. Okay, before that, if we want to create bromobenzene, so at the place of chlorine use bromobenzene. Same AlCl3 or FeBr3 reagents you can use as a Lewis acid. At the place of chlorine, bromine will join here, bromobenzene will generate, HBr will be the side product, and your acid, Lewis acid, will regenerate in a same form. Let's understand its mechanism. Step number 1, generation of electrophile. Here we have a role of Lewis acid. Chlorine which I have used, right now it is non-polar. Why it is non-polar? The both chlorine atoms are connected through sigma covalent bond. This is sigma covalent bond. Because electronegativity of both chlorine is same, so these electrons will remain in center. Like in this fashion I can draw it. They will remain in center. So 0 charge on this chlorine atom, 0 charge on this chlorine atom. That's why they are neutral. In this condition, this molecule can never attack on benzene. So first, its polarization is important. For polarization, we are using Lewis acids, in which central atom have a vacant orbital. Now we know, due to this vacant orbital can attract two electrons, means pair of electrons. So out of these chlorine, one chlorine will start making bond with aluminium, and automatically other chlorine will lose its electron, so it will become positively charged. Means after this attack, separation of chlorine will happen. The left hand chlorine will become +1 charged particle, electrophile, chlorinium ion, and this Cl will make a dative bond with aluminium. So like this. These 2 electrons this chlorine is using to make bond with aluminium. Because 1 electron is toward aluminium, so aluminium is getting extra electrons, so charge on aluminium will be -1 here. So AlCl4 is generated, and here we have our main particle, electrophile, chlorinium ion. Now this is first step. This is the role of Lewis acids. They create electrophiles, chlorinium ion, brominium ion, because initial particle is non-polar. So obviously to make it polar, its polarization, we are using Lewis acid. In this fashion, it will make them polar. Now second step. Second step, attack of electrophile on benzene. Now what electrophile wants? It is electron acceptor particle. That's why we call it electrophile. And who is the best source of electrophile over here? Electron over here, that is benzene ring. Benzene ring contains pi electron. We know pi electrons are perpendicular to the molecules and they are little outward from molecule. That's why they are easy target for electrophiles. Right now, all the carbons are same, symmetrical carbons they are. So it will attack any carbon and it will gain pi electron. Like suppose it is attacking on this carbon here. Now for bond formation, 2 electrons are required, but this chlorinium ion already lost its electron. That's why it have a vacant orbital. So to provide electron, the duty will be of this carbon on which it is going, this carbon. Now what this carbon will do, it will shift pi electrons toward itself and will use these pi electrons to make bond with chlorine. Like this. Rest molecule will remain as it is. There will be no change. Pi bonds here. Now check properly. This electron was of this carbon and this electron is shifted toward chlorine. So this carbon will have a vacant orbital and a +1 charge, means carbon will become carbocation. This carbon, the neighbor carbon from which pi electrons are shifting toward this carbon. Out of these 2 electrons, 1 electron is of this carbon and 1 electron is of this carbon, but both electrons are going toward chlorine. So this carbon is losing its electron, that's why vacant orbital will generate and this carbon will have +1 charge, carbocation. We call such complex also sigma complex. These sigma complex are able to show resonance. This is slow step. The second step is a slow step, that's why it is rate determining step. Means the speed of whole reaction will be decided by this step. Now this molecule is stabilized by resonance. Resonance we can draw. Check. Here we have a vacant orbital. Pi bonds are there. Hydrogens I am not drawing. You can understand hydrogens we have. And this chlorine will have 3 pairs on it. Now, resonance means movement of pi electrons. Due to this vacant orbital, this carbon will shift pi electrons here. And bond between this carbon and this carbon will generate. Here. Now, this carbon is losing its 1 electron. So now vacant orbital will generate on this one and +1 charge. And rest molecule will remain as it is. No change. Next time again, these pi electrons will shift here to satisfy this vacant orbital. Now double bond will generate here. This is as it is. Now one electron, this electron is shifting here. So this carbon will have vacant orbital now with +1 charge because it is losing its electron. This electron was of this carbon. It is losing it. That's why it is carrying a +1 charge. Rest molecule as it is. All hydrogens I can draw like this. Now further movement is not possible because alternate pi bond is not available. Now if you have to draw next resonance, so we have to repeat the cycle. Again it will go there and this step will generate and then this step. So the movement of pi electrons is in this area. So overall positive charge movement is like this. Chlorine is there. So this dot structures, these dots are representing overall movement area of pi electron, due to which positive charge is moving. Check, here we have a positive charge, now here we have a positive charge, and here we have a positive charge. This is second step. Generation of carbocation you can say, call it, or you can call it attack of electrophile on benzene ring. Now last step, third step is loss of H positive ion from sigma complex. As we can see, the sigma complex which we have made is unstable because the aromatic character of benzene ring is finished. Aromatic character means 6 pi electrons are not there now. So loss of aromatic character destabilize this molecule. So how it can bring it back? The carbon who made it unstable will make it stable back by breaking bond from hydrogen and shifting this sigma bond to make bond with carbon like this. So double bond will generate back with this carbon, and what will release out from here? H positive ion will be released out, and final product will be chlorobenzene. And this H positive ion will get stabilized by, in first step, AlCl4 negative was generated, this one. Now chlorine electronegativity is more than aluminium, as we know. So when bond, it is already unstable. AlCl4 is not so stable molecule. It is unstable also because it is a charged particle. So in the presence of H positive, between aluminium and chlorine bond will break and both electrons will shift toward chlorine due to more electronegativity. So Cl negative and H positive, they will combine to create side product HCl, and your AlCl4 will turns again to AlCl3. That's it. This is the end of the mechanism, in which in last step we are getting chlorobenzene, HCl and AlCl3 again recovered. This is the whole mechanism we have. In next videos we will understand next name preparation reactions like Sandmeyer, Gattermann and Balch-Siemann reaction. Thank you very much.